All right, let's go over some notes here for lesson 4-5. We're going to be dealing with mostly isosceles triangles, but also equilateral triangles. So first of all, talking about the parts of an isosceles triangle here. Just naming the parts. The two sides that are congruent are called the legs. They're also called sides, but the ones that are flat out congruent we call legs. The one side that is not would be considered the base. Now don't assume that the base has to be like on the bottom. If I rotate this paper, this is still the base, and these are the legs because they're the congruent sides. The two angles that form the base are called base angles. And the one angle that's not touching the base, this is the vertex angle. All right. Now we've got two main theorems based on isosceles triangle. The first one is isosceles triangle theorem, and the other one is the reverse, the converse of isosceles triangle theorem. So what is the isosceles triangle theorem? If two sides of a triangle are congruent, this picture you notice the two sides are congruent, then the two opposite angles are congruent. Now there's obviously three angles to the triangle, but if this is one of the congruent sides, you got to go across the triangle, and this angle B here is going to be congruent to, you look at the congruent side here, you go across the triangle, angle B would be congruent to angle A. All right, so you look at where the congruent sides are and go across the triangle, the opposite that side length is the congruent side. So don't pick angle C here. So in this picture again, it will be angle A is congruent to angle B. If two sides are congruent, then the two opposite angles are congruent. Sometimes I'll put this in pictures. If two sides are congruent, then the opposite angles are congruent. All right, so now we're going to talk about the reverse of that, or the converse of that. If two angles of a triangle are congruent, like angle A and angle B, then the two opposite sides are congruent. And again, you have three sides to the triangle, so you got to know which two of the three are congruent. You see where the congruent tick marks are. Opposite angle A is right here. CB, and then you see this congruent tick mark here, angle B, go across the triangle, this would be CA. All right, and don't pick AB. 4-5 is just a really random one. We're not going to see this theorem very much, but the bisector of the vertex angle of an isosceles triangle, so this dash 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 line is the angle bisector. There's a tick mark near the top and a tick mark here. So this dash 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 line is splitting this vertical angle of this isosceles triangle in half. Well, this bisector is the perpendicular bisector of the base. So down here at the bottom, you are 90 degrees and split bisect of the base. So CD, which was the bisector of this top angle, is perpendicular to AB, and CD bisects the base AB. Okay. Moving on to what we call corollaries to theorem 4-3, which was up here, isosceles triangle, and a corollary to 4-4, which again is the converse. Corollary is just kind of like a secondary theorem based primarily on theorem 4-3 or 4-4. 4-3 says if two sides are equal, the two angles are equal. Or reverse that, if two angles are equal, then two sides are equal. Well, now we're going to take it to three sides, and we're going to talk about not isosceles triangles, but equilateral triangles or equiangular triangle. If a triangle is equilateral, all three sides are equal, then all three angles are congruent. So in this picture, angle X is equal to angle Y, which is equal to angle Z. So instead of just having two sides that are equal, which creates two equal angles, this one has three sides that are equal, which creates three equal angles. And then you can put that in reverse. If a triangle has all three angles equal angular, then all three sides are congruent. And so in this picture, xy is equal to yz, which is equal to xz.